Hello, my friends, and welcome. I hope you're doing fine. And today we'll have a look at the next exercise of Exercism. It's called darts. So let's read. So darts, instructions. Write a function that returns the earned point in a single toss of a darts game. Okay, they will go and explain what darts is, what this game is. So darts is a game where a player throws a dart at a target. So you have a target, and then you throw darts. If you never saw it, they look like small toothpicks. I will say, and then you throw them, and they stick in a target, and then it says, in our particular instance of the game, the target reward 4 different amounts of points depending on where the dart lands. So also in the real one, you have like a dart target, and then there's different zones, and depending on the zone you hit, you get different points. So in our case here, we have 4 zones. So the first one is if the dart lands outside the target, player earns no point, 0. If the dart lands in the outer circle, you get 1 point. If you hit the middle circle, you get 5 points. If you hit the middle circle, the inner circle, you have 10 points. So the outer circle has a radius of 10 units. This is equivalent to the total radius for the entire target. The middle circle has a radius of 5, and the inner circle radius of 1. Of course, they are all centered at the same point. Of course. So you have in the middle, and then the outer, and then the middle, and then the outer. Yeah. So the coordinate of the middle is 0, 0. Okay. Write a function that gives a point in the target, defined by the Cartesian coordinates x and y, where x and y is real. Some math here. So there are these numbers. It's called real numbers and imaginary numbers. So that's an advanced math, but what they mean with real is like it's real coordinate. So it's an x and y. So that's all of it. So there's no imaginary numbers in there. Returns a correct amount earned by a dart landing at that point. Okay, so maybe it sounds complicated, but let's draw. As I always say. Always have notes. Always start with this. Do your research, think about solutions, and then come back, and coding is just a tool. All right, so let's think about everything now. All right, so we said we have a circle. We have the outer circle. Let's move this here. So this is our outer circle. Then we have the middle circle. Okay, looks good. And then we have the inner circle. I'll do different colors so we can see. Can we put this like maybe, yeah, here. Align. Perfect. So this is our thing. Can we actually change the... No, we can't, unfortunate. That's unfortunate. All right, so just imagine this is 1, this is 5, and the outer one is 10. Just imagine that's the case. So let's align it again. Perfect. So you throw your dart. If you hit, for example, here, you get 0 points. If you hit here, you get 1 point. If you hit here, you get 5 points. And if you hit in the middle of the circle, you get 10 points. Okay? So this is basically what we need to do. All right, so let's think about it. They said we have like, we can see it as a coordinate system. So what they mean. So you know, here's 0, 0. And then if it goes up, it's the y-axis. And if you go this way, it's the x-axis. Let me write this here. So this is y. And this is x. Okay? Oops. All right. Cool. So let me remove this. Oh, oh no. Return. Yeah. I want to remove this. Come on. This. Okay. Cool. So this is our coordinate system. And it goes from 0 here, 5, 10. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay? And this one as well, like 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right? Cool. So what they say is that we can see this also as a radius. So the radius from here to here is 10. Let me, do they have, let's do it like this. So the radius from here to here and the radius from here to here. So the first one is 5 and this one is radius of 10. Okay, cool. So let's download first the exercise, and then let's have a look at the test file and see if we get more information. Because at the moment, okay, we know how Dart works, the game, I mean, and we have an idea where the areas are and what we get from that. So let's have a look. First the test file, it's here. Let's make it like this. All right, and then the test file. All right, cool. Okay, so let me make it bigger so you can see. Cool, so we have a class here. The class is called Dart. And then we have in the test file, we have, for example, a score of -9 and 9. So let's begin. So you get back an integer. It's a 0, 1, 2, 3. So these are the scores that we get. And then it says, okay, this is the coordinate. So -9 and 9. Let's go back and see where -9 and 9 is. So usually when you are in a coordinate system and you get the first number is x, the second number is y. So basically, if they say -9, you go like 1, 2, 3, 4, 5, 6, 7, 8, 5, 6, 7, 8, 9. It's somewhere here. And this is the -9 because we're going this way. Usually on this axis, on this direction is the positive numbers. And the opposite side is the negative numbers. So we have -9 is somewhere here. And then +9 is someone here. So the first dart is here. Someone throw, hit this area. They get 0 points. So if we go back, we see they get 0 points. All right, so let's see the second one, 0 and 10. Well, x is 0 here. 10 is here. They hit this one. So they get 1 point, right? Yes. And then let's see -5 and 0. -5 is here. 0, well, the 0, they hit here. They get 5 points. And the last one is 0, -1. Well, 0, -1. We said that this radius is -1. Sorry, this radius is 1. So they hit this one. Okay? So they get 10 points. Cool. Now, let's see how we can implement this, right? I hope you get the idea how this works. First of all, as you see, it's not a rectangle. So basically, if we cannot say, okay, we take the numbers from 0 to 10 and everything in between 5 and 10, it's 1 point, and everything between 0 and 5, because it's a circle. So you saw that -9 and 9 is 0. And if you have a rectangle, it will be like this. So you hit something, right? Okay, so let's go back and see what we need to do. Cool. So we have the class Dart, and then we have score. And score get two integers, it's x and y, and gives back an integer. All right, that's easy. So we said we have a class, it's called Dart. Yep. Cool. We said we take an integer, and it's called, already forgot, score or scores? Score. Okay, let's copy this. Score, and then integer x, integer y. All right, cool. So how can we do this in Dart? So we talked about all of this. We said we have a coordinate system. So we're talking about points. And in Dart, there's, in this math library, there's a point class, which makes our life easy. So we go there and we see point. I'll link all the links in the description so you can just follow it. All right, so a utility class for representing two-dimensional positions, x and y. So that's perfect for us. So we have, for example, here, left top, point 0, 0. And that's basically when you program, and for example, if you do a Flutter widget, 0, 0 is always on top left, okay? Right bottom is, for example, here, 200, 400. So you have top left. Yeah, you need to see it on the other round. Let's do it like this. 0, 0, and then this is the right bottom, okay? Cool. So this is basically what we need because we are in the two-dimensional area. And then let's see what we can have here as a method. distanceTo returns the distance between this and another. This sounds interesting. No such a method. Square to distanceTo. Okay, we don't need this. This one we need. So this one sounds interesting. Let's have a look what it is. Returns the distance between this and another. So basically how we can calculate this this point here. So in the coordinate system, it's -9 and 9. But how can we calculate from here to here? Like, what is this? If you remember in school, you got something like a squared is b squared plus c squared, right? Remember this one? And with that, we calculate the is it called hypothesis? I forgot. Well, basically, you can say also a is the root square of b squared and c squared, right? And the distanceTo is basically doing that. So let's see here an example. So the distance of 0, 0 is 0. 0 to 10 is 10 because you have 0 and then 10 squared and square root is the same. And you got -10 and 100, so you have 110. Okay. Cool. So basically this is all what we need to solve this exercise. So we said, okay, the distance from here to here, if we calculate, let's calculate this. All right, so calculator, but not this. We need calculator. All right. So we said we have minus 9, but basically minus 9 squared is a positive number. So it's 81 plus 9 squared. You have 162. Okay. And if you take the square root of that, it's 12.73. Okay. And if we check that, it's outside the 10 zone. So it's 0 points. See how we can calculate that? It's easy, right? So basically using this easy math, we can calculate the position of that where you hit the dart, and then we can say, okay, it's outside the 10 zone. Cool. So hopefully you understood everything, the math and everything behind it. Now we can program. So let's go, let's go here. Cool. So the first thing what we need to do is to define our point, right? So we say point, dart position, for example, is, so we can point, and we can give that our x and y. Okay, so you see here, oh, there are some problems and stuff like that. Why? Because we need to import the library, the math library, and it's dart math. That's all. So now point, so now your program knows what point is. Before that, it was not clear what point is. It was not defined. Cool. Let me do this bigger for you. All right, so we have the first, so we have now our position. So if you have minus 9 and 9 here, you got the position. It's minus 9 and 9. That's in your coordinate system. That's your point. And now we have 3 things to consider. The first thing is the first point, if it's in that small circle, remember? In this one radius circle. So we can say if dart position, okay, dot distance 2. So we said we will use the distance 2 because it calculates for us the distance in the coordinate system. Cool. Oops. And we say what we need actually now. Oh, we need a reference point. This is what I forgot. So basically we need the 0, 0. So we have the reference point, the 0, 0, and then where it goes. So remember what we did here? This is the reference point, is 0, 0. And then we need to say from here to here, measure the distance. So we need to add that as well. And I'll do it as a outside this. I'll put it here. Point. Reference point, and say point 0, 0. So that's our initial position, and now every position we calculate the length of that, the distance we will get back. So we said dart position, that's our point where the dart hit, okay? So this is this point. Now we need the reference point, and then we measure how far is it, okay? distance to reference point. I'll copy this, paste it here. Okay, so that one, we said the first one, if it's smaller or equal to 1. So if we have that, if it's smaller and equal to 1, where are we? We are inside this circle, right? If we hit exactly here, or we hit inside, we are in this circle. So we get 10 points. So we return 10. Okay, understandable? So basically, dart position is the position where you hit the dart. Okay, this one. So in this case is -9 to 9. That's where you hit the target. Well, in this case, you missed. So, and we need an initial position, and that's here, 0, 0. And then we measure, okay, from here to here is, we calculate that it was, this one should be 12.73. Yeah. Okay. So that's the distance. Cool. All right. So this is the first one. So we have the second one is if dart position dot distance to refer point. All right. So if that one is smaller or equal to 5, so we return 5. And let's copy paste. So if this one is 10, then we return 1. Okay. And if you hit nothing, so we see else, we say return 0. Whoops. Or basically you can even say here return 0, because if none of these is true, well, you will return 0, right? You didn't hint anything. Okay, so basically this is how we get this. So let's test. Okay, so we need here print, and let's say darts dot. We have this. So let's try the first one that we got. It's -9 and 9. So let's test this out. What did we say? We should return, we should get 0 because it's outside of that target. So let's see. Yeah, it's 0. Cool. All right, so let's see what we get. So we have 0 and 10, it should get 1. So we have 0 and 10. We should get 1. Perfect. And let's have, for example, 10, 0 minus 1, or 1, it doesn't matter. 10, perfect. So let's say if they have, 0.7, 0.7, it should be also 0.7. It should also be 10. Is there something wrong? 0.7. Huh. Oh, it's double. All right. It's double. So, because we said we are taking only integers, that's easy to solve. We just convert this to num. So num is Good that this error appears. Num is double and integer. So either double or integer, it doesn't matter. It converts automatically. So it's easy for us. So we don't get an error. We don't confuse ourselves. Okay, 10. Perfect. So let's copy this and put it in here. Save. Where's our terminal? Here. So Dart, pocket. So let's test. Oh, by the way, we need to copy this and let's convert everything here to false. False, false, false. That's the fun part, right? All right, convert. Okay, looks good. Cool. So let's run the test. .run test. And let's see if everything is okay. Can you see it? Yeah. Oh, error. Okay, type point not found. Point isn't a type. Oh, yeah. Don't forget the import, as I did. So you need this here as well. So you put it in here. And then let's run the test again. So because it didn't know, okay, what is point? So you need to import the library. Cool, all tests passed. All right. I know this video is already half an hour, but let's go back and have a look how we did this. Okay. So the first thing is we have 3 areas. It's 1, 5, and 10. And we are in the coordinate system of x and y. And we are throwing our dart and we're hitting somewhere. If we hit inside this area, it's 1 point. Inside this area is 5 point. Inside this area is 10 point. So we said, okay, we hit here, for example, outside. So it should be 0 point. So it's -9 and 9. This is our coordinate. And we said, okay, this is our, what did we call it? Dart position. We said, this is our dart position. And this is our reference point. Our reference point is 0, 0. So we said, okay, we just measure the distance between this and this. And we calculate all of that. And it says the distance is 12.73. So in our example, it's outside of 10. So it is 0 points. It's outside of this circle, right? And then we did some other tests, and then we saw, okay, if we hit here, it says the distance is 5, and we get 5 points. Okay? And we used basic math that we learned in school to solve this problem. All right, cool. So I hope you could have learned, I hope you learned something. And as I always say, I'll repeat myself every time. Before you begin, before you do anything, see, you see the circles and everything here. Just do that before you begin to code, because if you start to code, I know what I'm saying. If you start to code, you're writing, then you will lose your focus because you don't know what you're doing. You're just focusing on the code part. But if you know what you're doing, you know how you solve the exercise, the coding, it becomes like, all right, it's a tool, I'll use it, whatever. Okay, what do I need? Okay. And I will include the links to point and the distanceTo method in the description. So this is how you solve darts. If you like it, show me with a like and sub to my channel. And I see you next time. Steve out.